Now let's discuss how to allocate dynamic memory for 1D array. Okay. Hash include stdio.h hash include stdlib.h because I have to allocate memory dynamically. Okay. The execution program starts from the main function. So first I'll declare n, size of the elements. I'll get the input value from the user. Scan of %d, ampersand n. I'm going to get the n elements from the user. So I'll declare a variable n. So memory will be allocated for this. So 1000. The variable is n. So for this variable n, I have got the input value from the user. Let's assume the value of n is 5. So I'm going to get 5 elements from the user. Now I'm going to declare one more variable called pointer variable, int arr. So first memory has to be allocated for this pointer variable. Arr, I'll give the address to be 2000. Fine. Initially I'll have the value as null. Done. Now I have to allocate memory dynamically. So I'll use a function called Calloc. So first I have to give cast type because Calloc function returns me a void pointer. I'm going to store only integer values and I'm going to store integer values. So I have to typecast to int star. So Calloc n size of int. So what happens? 5 blocks of memory will be allocated. Okay, I'll give the address to be 3000, 3004, 3008, 3012, 3016, and I'll initialize all the value is 0. Fine. And after this, what I have done, this base address will be taken and that will be stored in ARR. So the base address is 3000, that will be stored in ARR 3000. Done. Memory has been allocated. Now after allocating the memory, I have to get the array elements from the user. So for int I is equal to 0, I less than n, I plus plus. So I have to get the first element, scan of %d, arr plus I. So already discussed, when I give arr plus I, what happens here? So arr is having 3000. Okay. So when I give 3000 plus I, it is considered as 3000 plus I value is 0. So when I give I 0, that will be implicitly multiplied by size of the data type. So 0 into 4, that is equal to 3000. The first index value, I'll have the input value called 10. So when I give I value as 0, 0 less than 5 condition is true, I'll go here arr plus I. Arr value is 3000 plus 0, implicitly gets multiplied by the data type into 4, which is equal to 3000. Now if I want to store the next element, what happens? I value will be incremented by 1. It goes inside arr plus I. Arr value is 3000 plus I value is 1 into 4, which is equal to 3004. On the index value 3004, I'll store the next element called 20. Then I'll go to the next iteration. I value becomes 2. 2 less than 5, yes, condition is true. I'll go here. I'll get the input value called 30. That 30 will be stored here as 3000 plus 2 into 4, which is equal to 3008. On the index value, on the memory location 3008, I'll store the value. Then I'll go to the next iteration. I value becomes 3. 3 less than 5 condition is true. ARR plus 3. I'll store the value called 40. So here 3000 plus 3. When I give 3, it will be multiplied by the data type, which is equal to 3012. 3012. I'll store the next value is 40. Then I'll go to the next I value. I value becomes 4. 4 less than 5 condition is true. ARR plus 4, I'll get the value as 50. So 3000 plus 4 into 4, which is equal to 3016. I'll get the input value called 50. I have got the array elements from the user. Now after this, what I have to do, I have to print the values. So I'll go for loop. For int I is equal to 0, I less than n, I plus plus. now I'll allocate the memory. Printf %d, comma, I'll give space. Okay. Now if we want to get the values, so if I want to print the address, I'll give ARR plus I. Now value stored that, so give star before this. When I give star before this, what happens? Star ARR plus I. ARR plus I gives me the address. When I give star before that, value at this address. So the value present to the address will be printed. Okay. Now I'll print the array elements. So here I value is equal to 0. 0 less than 5 condition is true. ARR plus 0. So when I give ARR plus 0, what happened? 3000. Okay. So here star 3000. Star 3000, value of 3000 is 10. 10 will be taken and that will be printed as the output value. Then I'll go to the next I value. I value becomes 1. 3000 plus 1. So that is equal to 3004. So star 3004. So value of 3004 is 20. 20 will be printed as the value for the next I value. Then I'll go for next I value becomes 2. ARR plus 2. When you give ARR plus 2, what happened? Star 3000 plus 2. 3000 plus 2 into 4, which is equal to 8. So star 3008 will give me the value called 30. So 30 will be printed as the output value. Then I'll go next iteration. I value becomes 3. 3 less than 5. Yes, condition is true. I'll go here 3000 plus 3. So which is star 3012. Value at 3012 is 40. 40 will be printed as the output. Then I'll go next I value. I value becomes 4. 4 less than 5. Condition is true. I'll go here 3000 plus 4. That is into 4. Which is equal to 3016. Star 3016 is equal to 50. So the value 50 will be printed as the output value. Then I'll go to the next iteration. I value becomes 5. 5 less than 5. Condition becomes false. I'll come out of the for loop. Then I'll give free ARR because the allocated memory has to be deleted once the program got over. So I'll use a function called free. Then I'll give return 0. That's all. Program got over. Let me run the code now. I'll give n value as 5. I'll give 10, 20, 30, 40, 55 elements. I've got the output value. This is how I have to allocate memory dynamically for 1D array. Now let's discuss for 2D array. Now let's discuss how to dynamically allocate memory for 2D array. Hash include stdio.h, and I'll input one more header file called stdlib.h. Okay, so the execution of the program always starts from the main function. So first I'll declare int star star ARR. So 2-dimensional array. So I've declared it double pointer. So memory has to be allocated for ARR. ARR, let's assume the address to be 1000. Fine, I have allocated memory. Now I'll declare two variables R and C to get the row value and the column value from the user. Scanf %d because I have to get row value and the column value from the user. Row value and the column value. Fine. I have got the input value from the user. Let's assume row value equal to 3 and column value equal to 4. Fine. Now I have to allocate memory. So I'll give ARR equal to int double star because it's a double pointer, right? ARR is a double pointer. So I have to typecast to double star Malloc. Okay. R into, so row value, right? R into size of int star. So here I am allocating the memory. Why? Because now first I'll allocate the memory and then I'll tell you why am I giving instead of integer I'm giving int star. Okay. R value is 3. 3 into size of int star. Let's take 4 bytes. I'll allocate 3 blocks of memory. Okay. So let's assume this address to be 2000, 2004, 2008. 3 blocks of memory has been allocated. Here I'm not going to store the value. Okay, I'm going to store the address here. That is why I have given int star, size of int star. If I'm storing an integer value, I can give size of int. But here I am not going to store an integer value, I am going to store the address. Okay, so what happens here is this will allocate memory, this line. So in double star malloc or into size of int, this will allocate memory. This is the allocated memory. After that, the base address has to be taken and that has to be stored here. This base address will be stored in ARR. So double pointer will contain the address of a single pointer. So this is going to store a single pointer address. So 2000 will be stored here. Fine. So I've got 2000 now. Next, I have to allocate memory for each and every row, because every row has columns, right? For that I have to allocate memory. For that I'll take a for loop for int I is equal to 0, I less than or I plus plus for every row. So star ARR plus I. Why am I giving star ARR of I? I'll tell you. Is equal to int star, okay, typecasting malloc C into, because for every row we have columns, right? So how 2D array works? So if I take a 2D array, let's take 3 rows and 4 columns. Okay. So this is a 2D array. So what I have done is, now I have allocated totally how many rows are there. For that I have allocated the memory. Now for every row, how many columns are there? I'm going to allocate memory this one. For every row, 4 columns are there. So I have taken a for loop to iterate the number of rows. For every row, I'll allocate memory for all the columns. That is why C into size of int. Done. So now what is my I value? I value equal to 0, I less than or I plus plus. I value is 3, 0 less than 3, condition is true. If the condition is true, I'll go here, I'll allocate. What is my column value? 4. 4 into size of integer, 4 into 4, 16. 16 blocks of memory will be allocated first. Okay, first let me allocate that memory. See, 16 blocks of memory I have allocated. Okay, let's assume the address. This address I'll consider it to be 3000, 3004, 3008, 3012. So I have allocated the memory. After allocating the memory, base address has to be taken. Okay, I'll take the base address. What is the base address? 3000. This 3000 has to be taken. Where should I store? ARR plus I. Okay, what is ARR value? ARR is 2000. Okay, 2000. Let's check the calculation. 2000 plus I value is 0. 0 into 0, size of the data type. So that is equal to 2000. In the memory location 2000 I have to store. But what I have given? Star value what? So in the memory location 2000, what value I have to store is the base address of this. What is the base address? 3000. This will be stored here. So before watching this, I suggest you to watch the concept of pointers, because in pointers I have explained why am I giving storing in this place. Value at. So star 2000 says value at. So value at 2000 here in this place I have to store the base address 3000. Now I'll go to the next I value. I value 0 got over. Now I value is 1. 1 less than 3. Yes, condition is true. I'll go here. If the condition is true, again I have to allocate memory. For what? C. C value is 4. 4 into size of integer. There is 16 blocks of memory will be allocated. Okay. 16 blocks of memory is allocated. Done. After allocating the memory, let's assume the address 4000, 4004, 4008, 4012. 16 bytes of memory has been allocated. After allocating, thus that base address has to be taken and that has to be stored in ARR plus 1 star. So ARR is 2000 plus 1 into 4, that is 2004. In the memory location 2004, I have to store this base address. What is the base address? 4000. See, 4000. I've got. Now what I have to do? I'll go for the next iteration. I value becomes 2. 2 less than 3 condition true. I'll go here. I'll allocate the memory. C value is 4. 4 into 4, 16 bytes of memory has to be allocated. Fine. I'll allocate 16 bytes of memory. I'll give the address to be 5000, 5004, 5008, 5012. 16 bytes of memory has been allocated. After allocating, the base address has to be stored in ARR plus I star. So ARR 2000 plus I value is 2 into 4, that is 2008. So value at 2000. So value at 2000, that place I have to store the base address of this. What is the base address of this? 5000. So 5000 will be stored here. That's all. I have allocated the memory. So now I have got two-dimensional array. See, this is one dimensional, one dimensional, one dimensional. So this base address will be stored here. This base address I have stored here. This base address I have stored here. Now this base address have been stored in ARR because it's a double pointer, right? So this is a double pointer and this is a single pointer. Fine. This is how the memory is getting allocated for two-dimensional array. Now if I want to store the values, okay, so I'll get the input value from the user. For int I is equal to 0, I less than row I plus plus. Now I'll go for column. For int j is equal to 0, j less than column j plus plus. So I have to get the input value from the user, right? Scan of %d find, because I'm going to get an integer value. Now we have to give the address correctly. That is nothing but star ARR plus I plus j. Okay. So let's take I value equal to 0, 0 less than 3, condition is true. Yes, condition is true. I'll go here. J value is also 0, 0 less than 4, condition is true. Yes, I'll go here. First, ARR plus I. So I'll take this statement, I'll copy, I'll explain with the pictorial representation. Let's go step by step. So here ARR plus I. What is my ARR value? 2000. 2000 plus I value is 0. 0 into 4, that is equal to 2000. Got it? Star 2000. What is the meaning of star 2000? Star 2000 means value at 2000. What is the value at 2000? So value at 2000 is 3000, which is equal to 3000. Okay, I've got this. Again I've got plus j. Plus, what is my j value? 0 into 4, which is equal to 3004. On the memory location 3004, sorry, 3000, because 0 into 4 is 0 only. On the memory location 3000, I'll store my first input value called 10. I'll just combine all these things so that you can understand this very clearly. Yes. See, ARR value is 2000 plus I value is 0 into 4. 2000. Star 2000 is value of 2000 is 3000 plus j I have given plus 0 into 4, that is 0. So 3000 plus 0 is 3000. On the memory location 3000, I'll store the value called 10. Now I'll go to the next j value. Now j value is 1. So when j value is equal to 1, again check. Okay. So ARR value is 2000. Okay. Plus, what is my I value? I value is still 0 into 4, which is equal to 2000. Fine. Star I have given. So value at 2000 is 3000. So I have got the value 3000 plus j. What is my j value? J value is 1 now. 1 into 4, which is equal to 3004. So in the memory location 3004, I'll store the next input value called 20. So I have stored 10, 20. Next j value. J value is incremented by 1, which becomes 2. 2 less than 4, condition is true. I'll go inside. Okay. I'll go inside. I'll just combine this. Let's explain the step by step order. ARR value is 2000 plus I value is still 0 into 4, which is equal to 2000. Star 2000 is 3000 plus j value. J value is 2 now. 2 into 4, which is equal to 3008. On the memory location 3008, I'll store the next input value called 30. Next, j value becomes 3. 3 less than 4, yes, condition is true. I'll get the next input value from the user. So how can I get the next input value? Now ARR value is 2000 plus I value is still 0 into 4, which is equal to 2000, star 2000. So star 2000, the value is 3000 plus j. What is my j value? 3. 3 into 4, which is equal to 12. So 3000 plus 12 is 3012. On the memory location 3012, I'll store the next input value called 40. Done. I've got the next input value called 40. I'll store here. I'll go for next j value. J value becomes 4. 4 less than 4. Condition becomes false. I'll come out of the for loop. Then I'll go to the next I value. I value becomes 1. 1 less than 3. Yes, condition is true. I'll go here. I'll start the iteration again from 0. Okay. Let's check. What is my error value? What is my error value? 2000 plus I value is 1. So 1 into 4, which is equal to 2004 star 2004, which is equal to value at 2004. What is value 2004? 4000. 4000 plus j. What is my j value? 0. 0 into 4, which is equal to 4000. On the memory location 4000, I'll store my next input value called 15. I will store next input value 15. Next j value is incremented by 1. 1 less than 4 condition is true. Yes, I'll go here. ARR value is 2000 plus I value is 1 into 4, which is equal to 2004. Star 2004 is 4000. Okay, equal to 4000 plus j value is 1. 1 into 4, which is equal to 4004. So the next value will be stored in the memory location called 4004. So 25. Then I'll go to the next j value. J value becomes 2. 2 less than 4 condition is true. I'll go here. I'll get the input value called 35 from the user and I'll store. So here 2000 plus I value is still 1. 1 into 4, which is equal to 2004 star 2004. The value is 4000 plus j value is 2 into 4, which is equal to 4008. So in the memory location 4008, I'll store my next input value called 35. Then I'll go to the next j value. J value becomes 3. 3 less than 4 condition is true. Yes, I'll get the input value called 45. So what happened? 2000 plus I value is still 1 into 4, which is equal to 2004 star 2004 is equal to value with 2004 is 4000 plus j value. J value is 3 now. 3 into 4, which is equal to 12. So 4012. On the memory location 4012, I'll store the value called 45. Fine. I'll go for my next j value. J value becomes 4. 4 less than 4 condition becomes false. I'll come out of the for loop. Then I'll go to the next I value. I value becomes 2. 2 less than 3 condition is true. Again j value starts from 0 onwards. So this process gets continued. So it stores the value in this place. So let's see how 5000 is coming here. So what is my ARR value? ARR value is 2000 plus I value is 2. 2 into 4, that is equal to 8. So 2008 star 2008. Star 2008 is nothing but value at 2008. What is the value at 2008? 5000. So 5000 is the memory location plus j. J value is 0 into 4, which is equal to 0 only. So on the memory location 5000, I'll store the next input value called 50. So I'll store the input value called 50. J value is 0. 0 less than 4 condition is true. I'll store the next input value called 50. Similarly, it stores all the remaining 3 values like 50, 60 I'll keep, 70 and 80. So I have got input value from the user. Got the input value from the user. Okay, in a pictorial representation, it will be like this in a 2D array. So here we have 3 rows and 4 columns, right? Okay, this is the 2D array. But in the memory representation, this is a bit, it will be like this. Okay. Now index values. With the index values, we can take this index value is 0, 1, 2, and here index value is 0, 1, 2, 3. That's all. Fine. If you want to print the value, just add one more star before this. That's all. Because we have stored the value in this address. Now if you want to fetch the value from this address, what should I do? I have to give one star before this. Star 5000. Value at 5000. I can get this. So just add one more star before this. You will get the value. Now I'll copy this. I'm going to print the elements, right? So I'll give printf, not scanf. I'll give printf. printf %d. I'll just give one more star before this. That's all. It will get the values and it prints. Let me save this and let me run the code. See, input value 3, 4. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. See, okay, I have not given space. Okay, after completing one column, I have to give a new line I'll give so that I can see in the matrix format. /n. So let me run the code. 3 rows, 4 columns, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. See here, I've got the output value. So this is how I have to allocate memory dynamically for 2D array. That's all.